Hey everybody, it's time for another Dev Diary. Lately we've been working on a new application that will be shipping along with Beaker, which we're calling Beaker.Network. The application is still a work in progress. It's pretty straightforward. You can browse around at people's status updates, post comments in threads, like things. You have a profile with all your posts, who you're following, and people that are following you. Here I have a lot of test data that I'm working with right now, which I'm basically using to stress test the system, find out how things will perform whenever I start putting data in there. The mechanics of the application are really straightforward. Everything is a file on somebody's drive, and each person is their own drive. If I click to view a status file, right now they're just markdown files. They'll probably change to JSON soon. So here I am as Paul Frazee. I have a feed folder, and inside of it I have my post. My friends are also a folder, and they're listed here as mounted drives. I can click open to them. You'll see a similar structure. They have a feed folder with their various posts, and then their own friends folder with their mounted friends as well. Likes are similar. Currently they're in the likes folder, and they're these .goto files, each of which point to, using the metadata of the file, what they're liking. Comments are also still not final, but they currently operate as folders with JSON inside of them, where the folder name is a slugified version of the topic that it's discussing. We're probably going to change that to use metadata in the near future as opposed to folder names. The way that the feed view is assembled is using queries. We have a query function which is designed specifically for this purpose. The method works sort of like you might expect for querying a file system, where you specify a series of paths that you want to check, and you can use globbing patterns to match multiple different files. Those results are then merged together, sorted by, in this case, the creation time. The order is reversed and we apply a limit. And here are the results. We have, at the moment, 1 post from me and then 9 posts by Kaufman Houston. And if I look inside of the actual feed, you'll see that that's exactly what we see in the feed view. I can list all the people that I'm following by querying my friends folder and asking just for the mounts. And I'm following 6 people, so here they are. If I want to see who's following somebody else amongst my friends, I can run a query for that as well. I check the path of friends, all of my friends, and then I look inside of their friends folder and I glob against that. And then I match against the mount saying, give me the mount inside of these folders that points at this drive. And this is our friend Kaufman Houston's drive. So when I run this query, we'll see a list of all of the different people that I follow that are following Kaufman Houston. And that gets us 4 results. To get a list of likes on a post, I run another query where I look inside of the likes folder for myself and the likes folder for the people that I follow. And then I check the metadata to see what their href is. And I'm looking to see who has liked this post right here. And so this is the address of that post. If I hit enter, we will see that there's only 1 like, and that's my address because I'm the one that did it. There are a couple of advantages to this approach. One of them is that there's absolutely no backend to the application. All of the business logic for running these queries are contained inside of this file that I'm looking at, which is 655 lines long. You can see, for instance, my function for listing the friends for a given author, so who has this person friended or who has friended this person. So you can specify an author or a target, and you run different queries depending, but the logic is relatively similar. And then I simply read all the profiles for them and return the results. Assembling the feed is also easy. You run the list function that I've written here. It runs a query, then a modified version of it where it also reads the files after running the query. You attach the profiles to each one of them, and then you return the results. Here's the function logic for creating a comments thread. You read all of the comments that point to a particular topic, you map them by URL, and then you simply assemble them into a tree structure using this logic here, applying a depth limit as well if you want, and then you return the results. Another advantage to this approach is that there's absolutely no indexing required. So if I land on somebody's profile that I've never seen before, the same code runs no matter what. I simply land on their drive and then read their information off of their drive and can construct it into this view. Because there's no indexing required, I don't have to wait for an indexer to finish. This is similar to if you were using a SQL database and you never specified any indexes whatsoever. All of your queries were running off of a linear scan. Now, it's not quite that bad because the way that the file system is structured, certain things are relatively fast to do. But in our scenario, creating those indexes takes time that we don't necessarily always have. The trade-off for building these applications will be finding out how fast the applications can run without any indexing involved, and then figuring out when we really do need to get an index involved. You can tell that the performance is basically okay. I'm working off of a relatively small test data set that's all locally cached, and frankly, I'd like to see this moving 4 or 5 times faster at least. This kind of setup really ought to be instant. And so we're spending some time using this application to debug our performance characteristics inside of Beaker as well as inside of the Hyperdrive stack to try to make sure that we're tuning everything as well as we can. Once we're sure that this approach is running as fast as it possibly can, we'll then move into an indexing strategy. There are basically 3 different indexing strategies we can use. 2 of them are the ones that we're going to look at. Both of them are on the reader side, which is to say that as a consumer of the information, I produce an index and then reuse that index for myself. Now, on the reader side of indexing, you can either do it inside of the browser or you can do it inside of a service. We're going to explore both of those. We think they're both really good options for the Hyperdrive ecosystem that we call the grid. So we will probably combine having the application sit there and crunch together indexes in the background so that you can see things like what's been liked really quickly. But we'll probably also build a service to do that so that you can instantly get that information and don't have to task your computer with it. The advantage of using a service to accomplish that is that you're able to get a much wider view of the information and get it instantly because the service is running all the time and handling that information for you. So that wraps up today's Dev Diary. Thanks for tuning in. We'll see you all soon.